So I know I didn't put it in there again. 33-year case of senioritis, maybe even 34 years now. But happy National Whooping Crane Day. I heard that one on the Big Cheese this morning. National Whooping Crane Day. So whoop whoop for the whooping cranes. Okay. Alright, so I'm going to give you 2 worksheets today. So we're going to do this one. There's one example I want to go through. It's got 5 different subparts. Okay. Then hand out the worksheets, and then tomorrow will be like a work day too. Okay, because I won't be in the pre-calc classes because I'm going on the senior walk with them. So Cruz is going to cover one, and Sean is going to cover the other. So yeah. Okay. So it'll just be kind of a work day tomorrow, and then we'll finish up on Tuesday, and then that's it. So good to go. Okay. Okay. So distance. If I'm trying to find the distance, I just plug it into the formula or plug it into the function, right? Yep. So if I'm finding the distance, that's a plug into the function. If I'm finding the AROC, then that is on an interval from A to B. It's going to be f of B minus f of A all over B minus A. Okay. We've done that all week. Okay. And if I'm going to find the IROC, then that's going to be the limit as H approaches 0 of f of t plus H minus f of t all over H. Okay? And we simplify and simplify and simplify until we can't simplify anymore, because then H should be gone in that denominator, and then we can send H to 0, and we find our IROC. Okay? Love it. So, t cubed minus 3t squared is our mathematical function. Okay? Distance from the starting position after 6 seconds. So that means I need to find f of 6. Six cubed is 216. 6 squared times 3, 108. 216 minus 108 is 108, and this would be in meters. So 6 seconds after start, it's 108 meters away. Find me the AROC on the interval 3 to 5. Agreed? 25 meters per second? Yep. Okay. IROC at any given time t. I'm just going to rewrite my f of t down here. All right, so we're talking, we got the limit as h approaches 0 of f of okay. So let's figure out f of t plus h. T plus h cubed is going to be t cubed plus 3t squared h plus 3th squared plus h cubed. If I remember my Pascal's triangle, there's degree 0, here's degree 1, here's degree 2, degree 3. So that's, and then we start with t's cubed, and we go down to t to the 0 power, and we would start with h cubed, and we would go up to h to the 0 power. So yep, that's it. Okay. You guys remember Pascal's triangle? So this is any binomial to the power of 0, right? Because anything to the 0 power is 1. Okay, and then to the power of 1 means you would be each would be 1. Okay, power of 2, then I add these two to get that one. Add these two to get that one. Add these two to get this one, so on and so forth, all the way down. It's a quick way of expanding binomials to powers. Okay? You just keep following that pattern all the way down. So we got this one. Then you'd have minus 3 t squared. Then you'd have minus 6 th. And then you'd have minus 3h squared. Okay. Okay, so then it's minus that. So it's going to be minus t cubed plus 3t squared. Because really it's minus and then minus a negative. So it's going to be, switch the signs there. Okay. This t cubed cancels out that t cubed. This negative 3t squared cancels out that positive 3t squared. Leaves me with the limit as h approaches 0 of 3t squared h plus 3th squared plus h cubed minus 6th minus 3h squared all over h. divide everything by h now. Yes? Oh. Now I can do what? Send h to 0. So anything with an h is going to go away. So that's going to leave me with 3t squared. 3th is going to go away. H squared is going to go away. Minus 6t. And then 3h is going to go away. So anything that still has an h in it goes away. So there is my IROC function. Everybody good on that? Anybody see a shortcut? What do you got?
You multiply the highest exponent by the exponent.
The highest exponent by the exponent.
The highest exponent is always going to be the t. And so it's t to the power of 3 is just going to be 3t.
Okay, so hold on one second. Let me bring this back down. Let me see if you, so f of t, my original function, was equal to t cubed minus 3t squared. Okay, so you're saying, this is kind of what I'm saying. You're saying this goes down in front.
Yeah.
So my IROC then would be 3t.
Well, I just don't know how to get the squared part.
Okay.
But the second part, you just multiply by 2.
Same thing again.
But you get rid of the t because only the highest exponent is the, or no, you keep the t. Because it has an exponent.
Yeah. So how, we got to figure out how we get that, how we go from 3 to 2.
Because I think you add the squared because it's cubed instead of squared.
So how can I go from 3 to 2? Say louder. Say it louder.
Subtract 1.
You subtract 1. Yes, exactly. Okay. So that is legitimate. This is a legitimate shortcut for polynomial functions. Okay. This doesn't work for rational functions. This doesn't work for square root functions, for any radical functions. This only works for polynomial functions. Okay. So, and that is a true shortcut that we can use. Okay. You take the exponent on each individual term of your variable, and you multiply it by the coefficient, and you subtract 1 to that exponent. Okay? So if I had, I'll make one up here now, and we can just quickly do this. So if I had g of t equals 9t to the 4th power plus 3t squared minus 7t plus 8. Okay? Right? Okay? So this first one, so the IROC function then would be what? Give me this first one. 36t cubed. Do we agree? 4 times 9, t, 4 minus 1 is 3. Okay? Alright? What's my next one? 6t. So 6t. Okay? Minus 7. Right? Okay? And then this constant just goes away. Okay? Constants just go away because they get washed out in the math. Okay? Right? So then this would be the IROC of this function. The IROC is also called the first derivative of the function. Okay? Position, the actual function is position, okay, or quantity, if you will, depending on whatever it is your function is a function of. Okay? Your first derivative, okay, or the IROC function, is rate of change. Okay? Velocity, change in volume, et cetera, et cetera, et cetera, whatever your function is of. Your second derivative, which we could do that same process again to this, okay, to get my second derivative, that's acceleration. That's how quickly your change is changing. Okay, right? So that's what you'll get to. That's what you're going to get to a lot to next year is derivatives, and then you'll get to antiderivatives, and yeah, so you'll go backwards. You go this way on the way up. Okay. All right. So our IROC function was 3t squared minus 6t. Okay? So find me the IROC at t equals 1. Anybody? -3. Which means what to me in terms of what the object is doing? It's going backwards. Okay. All right. Then let's find t equals 3. Nine. Which means what? It's so it changed direction and it's moving forward now. Which means what? Somewhere between 1 and 3 seconds, it stopped. Because it was moving backwards, stopped, and now is moving forwards. Okay? Alright? T equals 5. Which means what? Now that we're going forward, we're accelerating. Okay, we're accelerating as we go. Okay, so we can gain a lot of things from all of that. Okay, how do I know when my object is truly stopped?
Set 0.
What equals 0? Set the IROC equal to 0. Yes. Okay, so my IROC was 3t squared minus 6t, and I set that equal to 0. How am I going to solve that for t?
60.
No. I have to factor out a 3t. I can't just move it and divide because I lose a factor when I do that. Okay, so I can only factor. Okay, can't divide by a variable. Now what? No. Set the factors equal to 0. And solve, right? So I get t equals 0, and I get t equals 2. Okay? So now, let's talk about the motion of our object. Here I am. I'm at the starting point. Okay? What happens? Start by going backwards. For how long? 2 seconds. Then I stop. Then I go forward. And I'm accelerating the whole time that I'm going. Okay? Alright? Did you expect me to run? I thought about kicking the Crocs off and running because I'm not in 4x4 mode, so I don't want to fall and trip kill myself on the way out the door. So yeah. Okay. I want to say, oh, there is something down here. Oh, where is the object when it is stopped? Okay, so at t equals 0, where is the object? Oops. We'll do it algebraically, we won't do it graphically. Where is the object when it stops? At what?
0.
It's at the starting point, right? It's at 0, 0. How'd you get that? Plugged in 0 in for t in my original function, right? 0 cubed minus 3 times 0 squared is still 0. Okay? All right? So at t equals 0, object is stopped at the starting point, which is good. At t equals 2, well, that means I got to figure out what f of 2 is. So that's going to be 2 cubed minus 3 times 2, right? Squared. 2 cubed is 8. 2 squared is 4. Times 3 is 12. Yes? 8 minus 12 is negative 4. Yes? Okay? So then that's going to be, it's going to stop at the point 2, comma, negative 4, which makes sense because you just told me if we start right here, the first thing we do is we go backwards. Right? Okay? Now, graphically, let's take a peek at this. So we know that we are at 0, 0. We know that we are at 2, negative 4. Okay. When, actually, I lied. We also know that at 3 we're at 9? You sure? No, that's the IROC. No, I want to go back up here. We know at 6 we're at 108. So that's way off my chart, right? Okay? So that means that we're going up and up and up and up. Can we figure out this other x-intercept? What would I do to figure out my other x-intercepts? Because how many should there be? There should be 3 of them, right? Because my original function was f of t equals t cubed minus 3t squared.
Set the function to 0.
Set the function equal to 0? Okay. Do we have enough to graph this function? What do I know about t equaling 0? How many roots are there? There's 2 of them there, because it was t squared equals 0. So that means that's a kiss. So my function is going to come down, or come up from here, come up, kiss at 0, come back down, and then rapidly shoot up that way. It's a cubic function, right? We've seen them before. Looks like that. What can you now tell me about where the object stops graphically? Does it make you think about interpreting a graph now here for a little bit? So it stops. I'll put them in pink. So it stops. Oops, that's not pink. it stops there, and it stops there. What can you tell me about those points? Okay. Okay. Graphically, what can you tell me?
It's a vertex.
There isn't a vertex in it. In a cubic. What do you mean turning points? What do you mean by turning? Where it turns?
The graph turns.
What do you mean?
It goes the other way. Look upside down.
Okay, let's break that down. Okay, so left of 0 here. Okay, what is my function doing? It's increasing, right? Okay, so we're increasing here. As we get closer and closer to 0, we're increasing, but we're slowing down, right? Because we're not accelerating to 0, we're slowing down to 0, right? Okay, now we're at 0. Now what's my function doing? What's my function doing? Not my object. My function is now decreasing, right? Okay, so that's a change from increasing to decreasing, right? So we call that a point of inflection. It changes the function from increasing to, actually, let me put it this way, from increasing to decrease. Okay? So now we're decreasing because my function is going down, right? Okay? Now we get to this 0. Now what happens? Now it changes to increasing, so that point of inflection changes from increasing to decreasing, or vice versa. Okay? That's what's called a point of inflection. Okay? Changing from increasing to decreasing. Okay? So the zeros, that's where it stops, where the IROC stops, is where our function changes, because we change, in this particular case, we would be changing direction. Okay? We started at the starting point, and we went backwards first. We stopped, now we're going forwards. Okay? Or we're going the other, we're going the opposite direction.